make Sahara green again. Close your eyes and imagine a green Sahara. Yes, the Sahara Desert in northern Africa, home to some of the world's hottest regions and almost bereft of any rain. Not surprisingly, much of it is uninhabitable. However, around 6,000 years ago, the Sahara enjoyed regular rainfall and was covered in vegetation. Now, scientists are looking into making the Sahara green again. We'll look at exactly how they plan to do this and what the ramifications will be. But first, some Sahara facts. The Sahara Desert is the world's biggest hot desert. Only polar deserts in the Arctic and Antarctica are bigger. The Sahara stretches from the Red Sea in the east, the Mediterranean Sea to the north, to the Atlantic Ocean in the west. It covers 9 million square kilometers and makes up for almost 1/3 of Africa's landmass, spanning 11 countries. They are Egypt, Sudan, Libya, Chad, Tunisia, Algeria, Niger, Mali, Morocco, Western Sahara, and Mauritania. The Sahara is subject to some of the world's hottest temperatures, with the average daily temperature being around 30 degrees centigrade, or 86 degrees Fahrenheit. Despite the predominantly arid conditions, there are 500 species of plant and a variety of animals to be found in the desert. Most of the Saharan plants and shrubs grow low to the ground in order to protect themselves from winds which soak up moisture. Animals such as goats, gazelles, foxes, cheetahs, and camels all exist in the desert, along with numerous arthropods and reptiles such as beetles, scorpions, lizards, and snakes. There is very little rainfall in the Sahara due to the prevalence of high-pressure systems. So, remind us again, why does high pressure restrict rain? Basically, high pressure restricts air from rising above the Earth's surface. When air rises, it cools, which causes water vapor to condense, creating clouds and subsequent rainfall. The Sahara is in a semi-permanent high-pressure system, which maintains a constant dry and arid landscape with clear skies and almost no precipitation. Despite the Sahara's unforgiving climate, scientists and engineers are now seriously considering how to restore vegetation to the region, how to make the desert green again. And they are optimistic. But how exactly do they plan on doing this? Let's take a closer look. The use of wind and solar power has been widely acknowledged as the most effective means to increase rainfall and subsequent vegetation across arid landscapes. By building huge wind and solar farms across the Sahara, it's believed that not only could the desert undergo a significant transformation, but also become a crucial energy source. First, let's see how wind and solar farms can produce rainfall. Wind turbines. Dr. Yan Li from the University of Illinois has been a key figure in studies relating to increased Saharan precipitation. Dr. Li says that wind turbines increase surface roughness, which in turn increases wind converging into low-pressure areas. This converging air has to rise, making it cool off and the moisture condenses, leading to increased rainfall. He estimates that the use of wind turbines can double the average precipitation, leading to increased areas of vegetation. Solar panels. Dr. Li also advocates the use of solar panels, along with wind turbines, to create more precipitation for the Sahara. He explains that solar panels allow for more solar energy absorption, creating a warmer surface. This causes more air to rise, producing precipitation. The overall impact of increased precipitation will bring huge benefits to the people in Sahara areas. The growth in rain-fed agriculture will see a huge boost in the cultivation of crops and the production of livestock. This is of huge importance in the Sahara. The Sahel region to the south and the Middle East are among the driest regions on Earth, with increasing populations. The Sahara is also a potential source of mass energy production. By establishing huge solar farms across the Sahara region, enough energy could be produced to satisfy global demands. However, the likely flow-on effects of rising world temperatures is a matter of conjecture. Greening the Sahara isn't limited to solar and wind farms. There are other initiatives gaining momentum, such as the exciting and ambitious Sahara Forest Project. The aim of the project is to reverse the process of desertification by restorative growth. It has been widely acknowledged that early human farming practices helped to accelerate the desertification of the Sahara. People cultivated the land, leading to deforestation and soil salinity. The Sahara Forest Project is based on utilizing the technologies of seawater greenhouse and solar power. Seawater greenhouses are a fascinating process and could play a crucial role in revitalizing the crop-producing potential of the world's arid regions. How does it work? Basically, seawater is pumped into the greenhouse, where it is evaporated and condensed into fresh water. This is done by solar desalinization, which removes salt and impurities from the seawater. Seawater greenhouses are 15 degrees cooler than the outside temperatures. This produces up to 130,000 kilograms of vegetables per year and up to 20,000 litres of fresh water per day. Magnus Borgen of the Sahara Forest Project says that saltwater-cooled greenhouses provide suitable growing conditions that enable year-round cultivation of high-value vegetable crops, even in desert conditions. By using seawater to provide evaporative cooling and humidification, the crop's water requirements are minimized and the yields are maximized. The Sahara Project saltwater pipeline is currently under construction and scheduled for completion towards the end of 2021. Water will be pumped from the Red Sea to bioplants for the production of crops and fresh water. This technology has already been successfully implemented in Jordan, one of the most water-poor countries in the world. Perhaps the most grandiose idea towards greening the Sahara would not only transform the landscape, but also help to reverse global warming. Cell biologists and climate modelers point towards afforestation projects across the Sahara and similar regions, such as Central and Northern Australia. Afforestation, or putting it simply, planting more trees, could play a two-part role. Firstly, the newly planted green regions would bring their own weather and rainfall patterns, enabling further opportunities for vegetation. Moreover, this new mass of tree cover would be able to absorb a huge amount of the world's carbon dioxide emissions, which is enough to warrant serious attention. How would it work? Firstly, by planting fast-growing and durable trees such as the eucalyptus and acacia. The trees could be irrigated by desalinated water, pumped through extensive irrigation networks. Of course, the costs would be huge. However, scientists argue that the global warming issue is also huge. Cell biologist Leonard Ornstein says the Sahara would be an ideal starting point. Such a scheme would provide jobs and investment, as well as a long-term source of sustainable wood that could be used as a biofuel to replace fossil fuels. In Niger, such afforestation is already taking place, with some truly amazing benefits. Since the 1990s, farmers have embarked on a tree planting campaign that has helped not only to stop the growth of the southern Sahara Desert, but produced fertile, farmable land. From trees come leaves and fruits, which provide food, fodder, and organic matter to fortify the soil. The benefits form a perfect cycle. More livestock equals more manure, which further enriches the soil, enabling crops to be grown. Tree seeds are spread so new trees grow. The trees also provide a crop shelter and help prevent soil erosion. These ideas and initiatives will not come cheaply. However, they can not only revamp one's arid, uninhabitable land, but also provide jobs, increase food production, and even reduce global warming. Are the ideas ambitious? Yes. Are they impossible? Not at all. With the cooperation of governments and international support, the investment in such schemes can become a reality. We may not have to wait 10,000 years for the next Saharan climate change after all. It may come in our lifetime.